So in this video, we're going to be talking about proportional relationships. And you might be like, proportional relationships? I've never heard about them. But the reality is you use them all the time. And so this is just kind of giving you maybe a more formal understanding of it. But basically, you know, a relationship is proportional if one quantity is a multiple of the other. You know, what does that mean? It's like I go to the grocery store and I buy 1 pound of something and I spend $2. If I buy 2 pounds, I'm going to spend $4. So I'm multiplying by 2 for every pound I buy. So that is a multiple of, you know, the original, you know, cost per pound. Now, you can find out if a relationship is proportional by looking at a table, a graph, or equation. So let's look at each one of those. Now, so for a table, they're going to have equivalent ratios in terms of this. So you can do y over x or x over y. I'm going to stick with y over x because it eventually will make more sense when you actually do graphing later on. So here I can look at this, and I'm looking for what is this change that's happening. So the changes in my x's are I'm adding plus 3, 3 to 6, plus 3, 6 to 9, plus 3. And so I'm following with this plus 3 each time. And here with the y's, plus 7, plus 7, plus 7 to get the next term. So here in terms of this ratio, I'm looking at this change in x over change in y. But you can also, you know, I'm going to kind of ignore this first one because that gets a little bit more confusing. But I'm looking for this change here. But I could also just write these ratios. So I'm going to do x. I'm going to do the y first. So let's say 7 over 3. I'm going to write another one in here. 14 over 6. And what's cool about these is you can tell if they're equivalent because I should be able to simplify this. And 14 over 6, when it simplifies, is 7/3. So I end up with equivalent ratios. And obviously, if I'm not buying anything, I'm not paying anything. But the other ones are all going to be these multiples, you know, equivalent fractions. Okay. Once again, a ratio is just a kind of a fancy word for a fraction when it's, and obviously it can be written as a fraction. Now, the other way it can we can kind of tell if something's proportional is by looking at a graph. So here's the graph for this particular thing, which says 3 pounds of chicken costs $7. What is the cost per pound? So the kind of requirements for a graph to check it to see quickly if it's proportional, straight line, so boom, straight line. And second, it has to go through the origin, so it has to go through the point 0, 0. So this graph is proportional. Okay, so we know it's proportional because the ratios simplify to the same amount. We know it's proportional because the graph is as a line and it goes to the origin. And then the other piece is that you can write, you can check and see if you can write an equation. And the equation is in this particular form, which is y equals kx. And k is this thing called a constant of proportionality. It's the thing you're multiplying by. So it also can be called like the unit rate or the scale factor, depending on if you're talking about speed or cost per pound or something like that. So I'm you know, buying 3 pounds of chicken, you know, and how much am I spending? Okay, so I'm spending a particular amount each time. So that's the constant of proportionality. And in this case here, it was that ratio that we simplified to, 7/3. So once again, you can look at the table and write ratios. They're equivalent. Goes through a straight line. It's a straight line and through the origin, and you could actually write it in an equation y equals kx. Now let's look at an example where it's not proportional. So here's another example. The county fair costs $5 to enter, and then you pay $1 per ride. So once again, we can look at table. The table has to have the point 0, 0 on it. If it doesn't have the point 0, 0 on it, it's not going to be proportional. So you don't even need to do anything. But you could also write those ratios and look at that. 6 over 1, 7 over 2, 8 over 3. If you simplify those, they're not equivalent fractions. So that tells you that this is not proportional. So once again, you can look at a table, looking at the ratios. You can look at the graph. This is a line, but it doesn't go through the point 0, 0. So we know that that's not proportional because it doesn't go through the point 0, 0. It's got this at. Whenever you have an equation, okay, and the third part was looking at the equation. Whenever you have an equation that has a plus, yeah, there's a multiplier here, but we're also adding something, okay? So in this case, it's not going to be proportional because it doesn't go to the point 0, 0. Okay, you've got this thing, and then when we did our ratios, they didn't simplify to the same number, okay? So, and once again, we see examples of proportional relationships in life, but we also see a lot of things that are not proportional. So it's really good to have an understanding